Welcome. So in this lecture, I'm going to go through a bit on the p-test and comparison tests, like actually practicing using them. So let's go ahead and get started. So the first that I want to check is, so this will be example 1. And I want to know whether the integral from 3 to infinity of dx over x to the 3 halves converges or diverges. Okay, and if you look at that, right, so for this one we can just use the p-test. So we're going to use the p-test with, right, and so we have that 3 halves, so p equals 3 halves is greater than 1. Okay, so that's going to give me that this converges. Okay, so that's a quick application. Let's do another one. So example 2. So then we want to know, so the integral from, now we want to go from 3 to infinity of dx divided by, and then we want to have x times the square root of x plus 1. So we already have our dx there, so we don't need to add that in. All right, so does this converge or diverge? So we can't directly apply the p-test, but we can kind of combine this with the comparison test. So we know what this is kind of less than. Okay, so we have that 1 over x times the square root of x plus 1. Right, so this is bigger. When the bottom is bigger, the whole thing is smaller, right? Bottom bigger, whole thing smaller. So this is actually less than 1 over x squared. Okay, and sorry, 1 over x times, that was silly. I didn't mean to write that. 1 over x times the square root of x equals 1 over x to the 3 halves. Okay. So what does that give us? Well, we know that this one from up there, so this converges. Right, so now we can use the comparison test. So this is going to say that this is converges. Okay, so we know that this integral converges from example 1. So the integral from 3 to infinity of dx over x to the 3 halves converges by example 1. Okay, and so we can use the comparison test. Okay, and so we can see that this one converges using actually the previous one, and the fact that we know that this is actually smaller than the previous one for all x values in our interval, which allows us to use the comparison test because we know that this one converges by what we did in example 1. Okay, so I hope that makes some sense. And I guess the other tricky part in here is to realize that the bottom here is bigger, and when the bottom is bigger, the whole thing is smaller. Okay, so now we're going to look at example 3. Okay, so we have the integral from 2 to infinity of, and then we have, so I have dx over, and then I have the cube root of x. Okay, and this is again converges or diverges. Converges or diverges. Okay, and so we can kind of look at something here. So what is this here? So this here is x to the 1/3. Okay, so now we can use the p-test again, and we have that 1/3. Okay, so we're going to use the p-test with 1/3, which is less than 1. Okay. And, okay, so this is going to diverge, right? So in this case, because this was greater than 1, it converged. In this case, because it's less than 1, this diverges. Okay? And then we're going to go through one more. So let's take, this is going to be example 4. So now I want to take the integral from 2 to infinity. And I'm going to go pi squared minus sine of x over the cube root of x dx. Okay? And we want to know again whether this converges or diverges. Okay, and now we can do this comparison with the one we just did. I did do these kind of with something in mind. Okay, so we notice that this is always going to be bigger than that. Why? Because this you can test. So sine is always bounded between -1 and 1. So this we're going to use. So this is always less than or equal. So this is always bigger than or equal to -1, less than or equal to 1. Okay, and pi squared is really quite big. This is like bigger than 9. Okay, so this is definitely bigger than 9. So even when I'm like adding or subtracting, I'm getting something between like 8 and 10. Okay, sorry, 7. Wait, I'm adding or yes, 8 and like 11 or something. Okay, so this thing is going to be, the top is bigger than 1, which tells me that it's bigger than this. Okay, so I have that pi squared minus sine of x is going to be greater than 3 times the square root of x, which is greater than 1. Sorry, this is going to be greater than 1 over the cube root of x, and we've already dealt with, right? So now we can use a comparison test. So the comparison test says, that's just going to give us that this integral from 2 to 3 of pi squared minus sine of x over the cube root of x is going to diverge. So this kind of like allows us to combine them, which is really kind of useful. So using the p-test, you can often figure out, you know, whether these 1 over these powers of x is going to converge or diverge when you take the integral. And then, so if you get something that has something like that in the bottom or some kind of polynomial, so you can do some kind of comparison, then you can actually often use our knowledge from the p-test and the comparison test to determine whether each of these converges or diverges. Okay? So I hope that makes some sense, and I'll see you in the next lecture.